Hi and welcome to my video on fractions, and the point of this video is to help you moving forward in the math methods and just make sure that you've got all the basic skills that you need. So let's start with a fraction and just denote some elements of this fraction. 1 over 7, which is sometimes called a seventh. So this fraction has two components. It has this top bit here, which is called the numerator, and it has this bottom bit here, which is called the denominator. And I'm going to refer to these as we move forward. So let's start with the simple bit, and this is a bit of an unusual simple bit, but the first simple bit is that when you move into math methods, you're going to need to be able to apply the operations to fractions, and you'll need to be able to do that fluently. So the simple bit is actually multiplying and dividing, would you believe? So let's take an example. 2/3 times by our little starter fraction, 1/7. Now this is a unitary fraction, by the way, whereas this one's not, because this has a 1 on top and this has a 2, so the 1 on top, sometimes they're called unitary fractions. If you're multiplying fractions, it's really trivial. All we do is we multiply the numerators and we multiply the denominators. So we get 2 times 1 over 3 times 7. So that's the first bit. That's the multiplication one. And to simplify that, I get 2 over 21. And of course, I need to just check that this doesn't then simplify down, and 2 and 21 don't have any common factors, so that's its lowest possible terms. So there's my multiplication. Now let's have a look at another one, this time a division. And we'll stick with the same fractions. 2/3 divided by 1/7. So what I'm going to do here, when you divide fractions, what we do is we reciprocate. So I'm going to reciprocate the second fraction and turn it into a multiplication question. So reciprocation, that's a really important word and an important approach, and you'll need to be able to do this in the topic of algebraic fractions. So here's my function, or here's my calculation, and I start with my 2/3, but now I multiply by the reciprocal of 1/7, which is 7 over 1. And I might show you a little application to this in a moment. But we get 7 over 1 here, I'm multiplying across there, and that gives me 2 times 7 is 14, and 3 times 1 is 3, 14 over 3, which can't be simplified, so there's no common factor here, but I can write it as this, because there are 4 3's in 14, remainder 2, so this is also equal to 4 and 2/3. But you know what, as you get further through maths, this becomes a little bit more useful. It's not really the proper way to write it, but if you've got more work to do in the question, if you convert it into this as a mixed number, and then you have to do some work later on, you'll probably have to convert it back to a top-heavy fraction. So you kind of may as well leave it there. Maybe at the end you change it into a mixed number. So there's our multiplication and division. What we're going to talk about now is addition and subtraction. So I'm just going to quickly go out the board and then we'll start again. Right, welcome back. So what we're going to do is add some fractions and subtraction fraction, and I'm probably going to stick with the same fractions actually, so let's see what happens here. So let's start by adding 2/3 plus 1/7. So this is a little bit more complex. It's not that bad, and you need to know how to do it. If I'm adding these two fractions, to add fractions I need to get them into a situation where I have the same denominator. So I'm looking to have the same number here and here. So what I'm actually looking for is something called the lowest common multiple of 3 and 7. Now, you can go for the lowest common multiple and it works really effectively, but if you don't quite know how to make it the lowest common multiple, you can also just use 3 times 7, which is what I'm going to do today. And then we can simplify later on, and that works just as well. So 3 and 7, when you make those lowest common multiple, it turns out 3 times 7 is that number, and I get 21 and 21. And this is still a plus. But what I need to do is ask myself, how did I turn that 3 into a 27? Into a 21, sorry. I multiplied it by 7, and to keep things fair and even and the same, I need to multiply the numerator by 7 as well. And 2 times 7 is 14. So I get 14 on top here. And now I'm going to think the same thing here. How did I get the 7 to go into that 21? I multiplied it by 3, and I multiplied the top by 3 to keep it fair and even. And of course that 1 times 3 gives me 3, and now I've got 4 21sts and 14 21st and 3 21st added together, and I just add the numerators to get 17 of these 21sts. So 2/3 plus 1/7 is 17 over 21. It's pretty abstract, but the process is pretty easy to follow. So what I might do now is I might do another one where I'll show you that process again. So this time, 3/5 plus, let's make it 1/10. Okay, now I've done something very deliberately here. So I'm going to show you there's two ways, and then we'll do one subtraction and leave it there. So 3/5 plus 1/10, let's say we blow it out to the just 5 times 10 as a denominator, which is perfectly fine. So I know here that I'm going to multiply this side by 10 and this side by 10 because that's this number. And I'm going to multiply this side by 5 and this side by 5 because that's this number. So they're the choices I'm making. It will give me the same denominator. It's a very procedural approach. And so 3 times 10 is 30, 5 times 10 is 50, plus 5 times 1 is 5, and 10 times 5 is 50. There we go, same denominator. I add those together and I get 35 over 50. Whenever you finish a question like this, you just have to make sure that you've got it in its simplest terms. 17 and 21 are both, they're not the nicest numbers. 21's got some factors, 17's prime, they can't simplify. 35 and 50 can. They can both be divided by 5. So I'm going to look to simplify by dividing the top and bottom by 5, and that will give me 7/10. And that's the best I can do. Now, there is another way you could do this. This is the procedural way. This will work every time, and you can do this every single time, that's fine. But another way to think about it would be 3/5 plus 1/10. I'm looking for the lowest common multiple. I don't want to go all the way out to 50 because I can see a better number. What I can actually see here is that if I multiply this by 2 and this by 2, the first fraction ends up with a denominator of 10 and the second fraction already has a denominator of 10. So the lowest common multiple of 5 and 10 is 10. That's the lowest number that they both divide into evenly. And so I'm going to change this to be 6/10 plus 1/10. And that of course is equal to 7/10, which is exactly what we wanted because that's our answer from here. So same answer, this time though we didn't have to simplify. Because we've got the lowest common multiple, there's no simplification involved. So I'll show you one other example, and it's very similar. So let's say I'll do a top heavy fraction one, 10/7 minus 1/3, something like that. Okay, but this time I'm just going to talk about the minus. The situation doesn't really change. So with the minus, we are looking for the common denominator, and in this case 7 and 3, they don't have any, they're something called co-prime. They don't have any common divisors, so I know straight away that just 7 times 3 will be our lowest common multiple. So I'm going to, and I'll do this in a different colour, I'm going to multiply this by 3, and this by 3, that came from that 3, and I'm going to multiply this by 7, and this by 7, that came from that 7, and I'm going to put that over here. I get 10 times 3 is 30, 7 times 3 is 21, 1 times 7 is 7, 3 times 7 is 21, and there's a negative in the middle, 30 minus 7 is 23, so this is now equal to 23 over 21. And this is top heavy, so it's a good answer, but if you need to write it as a mixed number, how many 21s in 23, how many denominators in the numerator, and in this case it's 1 and 2 remainder. Okay, so that's my video on multiplying, dividing, adding, subtracting fractions. There's some basic skills that you will definitely need to have because you're moving into a course, Mathematical Methods, with a tech-free paper. Hugely important. So of course ask your teacher if you've got any questions, practice these skills regularly and you'll do just fine. Thank you.